Hi, in this video we will discuss asset concept. Asset concept is a very famous concept in database systems, either a relational database systems or any other types of database systems. Asset is abbreviation for atomicity, consistency, isolation, and durability. We will start with the first concept, atomicity. Atomicity means all or nothing. Either we apply the transaction with all its steps and all the sequence of transactions successfully on our transactional system or on our database, or nothing will happen on the database system. And to understand more, let's take an example of a user or a customer is going to buy a product from a retail store. And let's say this product costs 10 units or $10. So this transaction from the customer contain three steps. First step is deduct balance from customer account. Second step is add balance to retail store account. Third and last step is decrease product quantity. And we have transactional system, and this transaction system current state is customer account has 100 units, store account has 50 units, and product stock has 5 units. So we will apply the transaction step by step on our database. First step, deduct balance from customer account. So instead of 100, it will be 90. Second step, add balance to retail store account. So it will be 60. Third step is decrease product quantity. So instead of 5 units in the stock, we will have 4 units. So in this case, all the steps of the transaction has been applied successfully. So we can say the transaction has been committed and completed successfully. Let's take another case. In the same use case we have, let's say first step of the transaction has been completed successfully, and second step failed for any reason, let's say for power failure, service failure. So in this case, this transaction is not complete, and we cannot leave the transactional system or our database with this state, because here transaction is not consistent. We applied partially one of the sequences inside our transaction. And according to atomicity concept, all or nothing, either all the steps of the transaction should be completed or nothing will happen. That means we need to roll back all the steps in our transaction that we applied on our transactional system. So in this case, customer account should be rolled back to the previous value or old value. And in this case, we say transaction is not successful fully, so we applied a rollback. So you notice here that in case we have a failure in our transaction, we didn't change the state of our transaction system. It is the same state after transaction and before transaction. Now let's move to the second property of asset properties, which is consistency. And by consistency, we mean that correlation or consistency of data should not change after the transaction is committed to the database. So we shouldn't have any inconsistent data in the database after we apply the transaction. Let's take this example that we described before in Atomicity and describe the consistency principle on this example. In this example, we have three steps inside one transaction. First step is to deduct the balance from customer account. Second step, add balance to retail store account. Third step is decrease product quantity. And this is the numbers before the transaction, and these are the numbers after transaction. So the normal case or consistent data before and after transaction will look like this. We deduct it from customer account, so customer account should decrease, and in our example it's 10, so it should decrease by 10. Store account should increase by 10, and the product stock should decrease by 1. So in this case, the data in our database is consistent because one transaction in the database in our use case means these three steps: decrease from customer account, increase in store account, and decrease in product stock. So in this case, we can say data is consistent before and after the transaction. Now, what will happen if we suddenly we found that store account has increased, but product stock in this use case is not decreased. It is still the same number. There is no logical relation between increasing the store account and product stock to be the same in this specific transaction. So this means data is inconsistent. So after we apply the transaction, data is inconsistent. And this is what we mean by consistency. So when we apply transaction on a database in general, transaction should not change the consistency of data in our database. In our case, successful transaction means product units stock will decrease and the store account will increase. So by consistency, we mean we shouldn't have unexplained or inconsistent data in our database after we apply our transactions. Third property from asset properties is isolation, and isolation means transaction shouldn't impact other transactions. Or let's say transactions shouldn't interfere with other transactions. And to understand more, let's take our use case. We have our customer is going to purchase a product from a retail shop, and we have transaction number one, and inside this transaction we have three steps, 1, 2, and 3. And this is the data before transaction 1. Store account has a 50, product stock has 5, and after transaction 1, store account should have 60 and product stock should have 4. Let's say at the same time we have another user going to purchase the same product. So we have transaction number 2 on the same table and on the same product or same attributes. So if we applied transaction number 2 at the same time at transaction number 1, or while transaction 1 is still in progress, and we apply transaction number 2, at this case, store account will be 80, considering that transaction number 2 will add 30 to store account and will detect 3 from product stock. So product stock will be 2. However, these values are not the correct values, because we still have transaction number 1 in progress and the values are not updated yet by transaction number 1. So correct values should be after applying transaction number 2, and of course after applying transaction number 1 first, the store account will be 90 and product stock will be 1. And that's because we applied this transaction, then we applied this transaction, number 1, then number 2. So when we applied transactions in sequence or in the correct order, we got the correct values. Because the issue here, if after we apply transaction number 2 and we have another business user is trying to read data from this table, he will get incorrect values. He will get totally wrong values. Because we still have transaction is not yet committed to the database. However, it is a transaction that came before the current transaction, which is transaction number 2. Transaction number 1 came first, then transaction number 2. So we should apply transaction number 1 to have consistent data. Then we apply transaction number 2 to have another consistent data. And this is what we mean by isolation. If you have multiple transactions targeting the same attributes and the same table, or let's say the same scope, it should be executed in sequence to not impact the consistency of our data. But if you have multiple transactions are mutually exclusive, that means transaction number 1 or transaction number X has no impact on transaction number Y. These two transactions or multiple transactions can be executed in parallel. But if we have multiple transactions targeting the same scope, that means we should be careful and apply transactions in sequence. So isolation means transaction must not interfere with each other and execution must be controlled according to interference between transactions. Transactions that mutually exclusive can be executed in parallel, otherwise isolation must happen. So simply, as we said at the beginning, transaction not impact other transactions. Last property of ACID properties is called durability, and we mean by durability, once data is written and committed, it will never lost. And this is a basic concept and important concept in databases or transactional systems. Because I cannot trust a system or I cannot trust a database if the data in this system or in this database is lost due to any kind of reasons, like server failures, power failures, or any kind of failures. I cannot trust the system then. So once I have a transaction that is committed to the database, I should be sure 100% that this data will never get lost. Because if this data got lost and the system or database cannot keep the durability of our data, I cannot trust this database. I cannot take decisions based on data available in this database. So durability is a very important property from ACID properties and also in databases in general. Now after we describe the four properties of ACID, now let's ask ourselves a question. Do we need the four properties of ACID in transactions? And the answer is yes. And let's take it one by one. We need atomicity to make sure that all the steps or all actions in our transaction has been applied completely and applied successfully. We need consistency to make sure that the data in our database after and before transaction are consistent and we don't have like a partially completed or partially consistent data. We need isolation to make sure that one transaction is not impacting another transaction, or one transaction is not interfering with the result or data of another transaction. We need durability because we need trust. We need to trust that database system can handle any type of failure and our data will not get lost. So actually, we need the four principles or four properties of ACID, which are atomicity, consistency, isolation, and durability. I hope now ACID properties are clear. Thank you.